Dear student, today I am going to teach you properties of integer over different operations: addition, subtraction, multiplication and division. And that only three property I am going to teach you: closure property, commutative property and associative property. Closure property is based on a two integer or more than two integer. Also you can tell that. Commutative property only based on a two integers, and the associative property is based on a three integer. So here we are going to see that which property is hold on which operations. Means closure property hold on addition, for a subtraction or multiplication or division. So we are going to check one by one. And what is a closure property? Closure property means that if we add for addition, we are going to discuss this closure property for addition. If we add two integers and then we get it another integer, then it said that closure property hold for addition. It is as simple as that. I will show you that. For example, if we take two integers, let a and b, so two integer, and let a and b two integers. If we add a plus b for addition, I am talking about addition. If we add a and b, then we get another integer. Then we said that this closure property hold for addition. Means that it is the same as it is. If we adding a two member of a same family and if we getting another number which is belong to the same family, then it is called a closure property. For example, if I show you that one, 2 plus 3, if we adding two integer, 2 plus 3, what we get it? We get it another integer 5, which is also belong to a same integer family. 2 is also integer, 3 is also integer. So, and one more example, if I take that minus 5 and plus 3, what you will get it, students? You will simply get it. Here is you know that how to add the two different sign of integers. Here is first we subtract that and put that sign which have a greater value. So 5 minus 3, you get it 2, and then 5 is a greater in this one, so its sign is minus 2. So minus 2 is also an integer. 5 is an integer, minus 5 is also integer, and 3 is also integer. If we adding two integer, we are getting another integer. Then we said that closure property hold for addition. So it means that what you will write it there, you will write that yes, closure property holds for addition. So yes, closure property hold for addition. Second one is that subtraction. So we are going to discuss about the subtraction. Subtraction hold for closure or not. It is also very easy. I have taken a and b, same integers. If we subtract a minus b, if a is greater than b, if we subtract a minus b, we also getting an integer. Means that we are getting a member which is belonging to the same family, that is integer. Suppose in this case, if I am taking that a is equal to 5 and b is equal to 4, so what you get it? A is greater than b, then we get it 5 minus 4, we get it 1. 1 is also belong to a integer. Means that yes, this subtraction is also hold for closure property. Now the third one is, we are going to see this, multiplication is hold for closure or not. It is also very easy. Dear student, it is also very easy for multiplication. If we take a and b, two integers, and if we multiply that one, if we multiply a and b, then we get it another integer. If we tell that c, in c is the product of a, b, in place of c I am going to write it only integer. If we multiply a and b, we are getting what we are getting it, that is also integer. Suppose if I am taking this a is equal to minus 4 and b is equal to 3, and if we are going to multiply this one, listen students, see this one here, minus 4 is going to be multiplied by 3, and you know that minus 4 is multiplied by 3, 4 3 is 12, and after that you will put the minus sign. So tell me, what about the minus 12? Minus 12 is the integer or not? Yes, that one is the integer. So for closure is hold for multiplication also. So dear students, closure property holds for multiplication. Then that one is very important, students. We are going to see that closure property will hold for division or not. Okay, so dear students, see this one very carefully. This is a closure hold for addition. A plus b is equal to an integer. Yes, no problem. Subtraction, if a is a greater than b, suppose we have taken an integer which is a greater or less, no problem. A minus b, whatever you will get it, that is also an integer, means that it is also belonging to the same family. And if we are taking a and b and multiplying that one, a is multiplied, what the product we get it, that is also belonging to the same family, that is also called a integer. So fourth point is a division. This closure holds for division is or not. We are going to see this one. Let with this example, we have taken a two integer, let a and b are two integers, and the value of a is equal to 10 and b is equal to, I have taken that b is equal to, suppose I have taken 2. First case, I am going to take that one. In this case, listen students, a divided by b, if it is an integer, then we can say that yes, this one is going to be whole. If it is follow all that for all integers, suppose in this case 10 divided by 2, what you will get it, 10 divided by 2, you know that 5 is an integer. In this case you are getting that integer, but you can see that it is not going to hold for overall. Suppose if another example I am going to take, that if I am taking that c and d, c or b are taking the same different value of a. Let another example, in this case it is hold for that one, but if I am taking this one more example, if a and b are same two integers and the value, I am going to take the different value, a is equal to 15 and b is equal to 2. In this case, listen students, in this case for a division, a divided by b, if you are getting an integer, then we can say that yes, it is a whole for division also. Not for only one case. If it is getting that one case you are getting it integer, then you cannot tell that. If it is follow all that in for all integers, then we can define that yes, closure will hold for division also. So here I have taken 15 and 15 is divided by 2. You know that if 15 is going to be divided, you get it 7.5 or 7 whole 1 by 2. So you know that 7.5 is not an integer, or you get it 7 whole 1 by 2. This is also a fraction. This is a decimal and this one is a fraction. It is not an integer, so it not belongs to a integer. It not belongs to a integer. So means we can say that if a and b are two integers and a divides by b is not getting a integer for all the cases, so it is simply we can say that it is not necessarily follow the division, is not necessarily follow the closure property. It is not good. It is not following properly for closure. So no, it is not following the division. Closure is not following the division property. Or division is not following the closure property. Closure is not following the division operation, and division operation is not following the closure property. Yeah, listen students, we have done that one, closure property. Closure property hold for addition, subtraction and multiplication. It's not a greater than, means any if a is a greater or less, then you will get it an integer if you subtracting that one. Here in division, if we have taken a and b two integer, if a divides b, you are not getting, always you are not getting an integer. Some cases you are getting that integer. So it is not, if it is follow all that for all integers, then we can say that this property hold for division. It's not equal to an integer. Okay students, next one is a commutative property. It's very important students. Commutative property. First we are going to discuss with this addition. So let the examples, let A and B are any two integers. Any two integers. Listen, from the commutative property, if we add A plus B, first we add A plus B is equal to, if we interchange that order of, in place of A we are going to write that B, in place of B I am going to write that A, students. So B plus A. So dear students, if A plus B is equal to B plus A, then we can say that if left side is equal to the right side, then we can say that addition holds commutative property. See that with example. I have taken an example here. Let A is equal to 4 and B is equal to 5. So take this left side, left hand side. Left hand side is equal to A plus B. So first we write it A plus B. So dear students, listen. 4 plus 5, what you will get it? You will get it 9. 4 plus. So dear students, I have solved that left hand side. You see this one, this is rule A and B are any two integer. Then the sum of A plus B is just opposite of it. We change the order of A and B. B plus A is also. If they are equal, then we can say that addition hold commutative property. So we have solved it here. Left hand side A plus B. We have solved it. We get it 9. And then we are going to solve that right hand side. Right hand side. You know that LHS and RHS, left hand side, and RHS is a right hand side. See this one, right hand side is a B plus A. B is a 5. 5 plus 4. What you will get it, students? In this case also you are getting it 9. So hence we can say that hence if left hand side is equal to the right hand side, if left hand side is equal to the right hand side, means that so addition holds commutative property. Commutative property. You can do some examples in your home also, students. Means that so addition holds commutative property for any integer. That property is correct for this one. So we can say that yes, A plus B is equal to, change the order of that one, B plus A. This property hold for commutative. Now that we are going to talk about this subtraction. So I am going to erase this one. For subtraction it is going to be hold or not. We are going to check this one. So for this one, if for subtraction, if we are subtracting, listen students, if a rule is that let A and B are any two integers, then if A minus B is equal to B minus A, if they are following this rule, then we can say that yes, subtraction also will hold for commutative. A minus B is equal to B minus A. So shall we check it? If it is not equal to, then we can say that no, it is not going to be hold for commutative. Let we have one example for this one. Let A is equal to 10 and B is equal to 15. I have taken A is equal to 10 and B is equal to 15. So left hand side A minus B. So A is a 10 minus B is a 15. So if we subtract this one, what you will get it, students? You get it minus 5, because one is a plus and another is a minus. You know that you will subtract 15 from, you can subtract 10 from 15 and put the sign which have a larger value. So 15 has a larger value, its sign is a minus, so we get it minus 5. So then after we are going to solve that right hand side. You know that right hand side is a left hand side. Right hand side is a b minus a. B is a 15 minus 10. What you will get it? You get it plus 5. So can you see this one? A minus b is equal to minus 5 and b minus a is equal to plus 5. Both are equal? No. Means that here you can see this one with this example. Hence left hand side is not equal to right hand side. Means that so subtraction will not hold for commutative property. Commutative property. So here you can write it. No. Here is this one. It is not hold for commutative. Yeah, students, subtraction will not hold for commutative. Next one is we are going to see this operation multiplication. Multiplication will hold for commutative. We are going to see this one with that example. If we take this rule is that one, if let a and b are any two integers, then if a is multiplied by b is equal to b is multiplied by a. In simply, I am going to somewhere it is in some books it is written that ab is equal to ba also. Means that a is multiplied by b and b is multiplied by a. Means if we are changing same, it is a plus b is equal to b plus a minus b is equal to b minus a. Here it is a is multiplied by b is multiplied by a. So if it is whole, if left side is equal to the right side, then we can say that yes, the multiplication holds for commutative property. With very easy examples, I am going to take these examples. If we take a is equal to 3, let a is equal to 3 and b is equal to 4. See this one. If we take this left hand side is a into b. I have taken that a is equal to 3 is multiplied by 4. What you will get it? That one is 12. Take the right hand side is b multiplied by a. B is 4 is multiplied by 3. What you will get it? You also get it 12. Means that left hand side is equal to the right. It follows the rule of multiplication over commutative. So means that we can say that yes, multiplication holds commutative property. So we can tell that yes, b is equal to ba. Means that a is multiplied by b is equal to b multiplied by a. So multiplication holds for commutative. Next one is for division. I'm going to tell you that rule for division, students. If we take a and b are same, that rule, if we take this a and b are any two integers, then if a and b are any two non-zero, we are not talking about the zeros. Non-zero means that its value is not a 0, means that it is a greater than or less than 0. It is not a 0, non-zero integers. Then a divided by b, if it is equal to b divided by a, then we can say that division will hold for commutative property. Let's we check with this examples. Example is that one. Let a is equal to 50 and b is equal to 25. I have taken that a is equal to 50 and b is equal to 25. I have taken that the value of a is equal to 50 and b is equal to, I have taken two integers. So can we see this one? So with these examples, let's take the left hand side. Left hand side is a divides by b. A divided by B means 50 is going to divide by 25. 50 is divided by 25. You know that 25 to the 50 means you get it 2. Means the value of A divides by B is equal to 2. Then you can solve the right hand side. Right hand side means the right hand side is B divided by A. Your value of B is 25. 25 divided by 50, and you know that if 25 is going to be divided by, you can write it like this, 25 upon 50. If you cut this one, you get it 1 upon 2. 25 ones are 25, 25 twos are 50. You will get it 1 upon 2, or if you change it into a decimal, you will get it 0.5. So 1 by 2 is a rational number or a fraction. You can tell that it is not equal to an integer. For any integer, 0.5 is a decimal. It is also not equal to 2. So we can say that. Now we can say that hence, so left hand side is not equal to the right hand side. It means that division will not hold for commutative. No, it is not going to be hold for commutative property. Dear students, we have done that closure and commutative. Commutative hold for addition. If A plus B is equal to B plus A, then we can say that yes, commutative hold for addition. Now we are talking about subtractions. Subtraction will not hold for commutative because A minus B is not equal to B minus A. So it will not hold for commutative. Multiplication. A is multiplied by B, B is multiplied by. If we interchange the order, then we are getting the same results. So means that multiplication also will hold for commutative. For division, if A divides by B is not equal to B divides by, both are not equals, left side is not equal to the right hand side, it means that division will not hold for commutative. Here we are talking about the two integers, but associative is hold for three integers. Associative holds for three integers. Associative holds for three integers. So associative property I am going to talk about for addition. First one I am going to talk about for addition. Associative, it will hold for addition is or not. So I am going to check this one. Rule is, if we take if A, B and C are any three integers, any three integers, okay, so then student, then A plus in bracket B plus C is equal to A plus in bracket last two integers we have put it in bracket. Then after we have taken first and second in a bracket, and the last one is outside of this bracket. So if A plus in bracket B plus C is equal to A plus B plus outside of C, if both that left side is equal to the right side, then we can say that addition will hold for associative. So this one we are going to check with that example. Yours let example is that let that example is very important. So let A is equal to -4, B is equal to 3 and C is equal to 10. We have taken out three integers, the value of three integers A, B and C. A is equal to -4, B is equal to 3 and C is equal to 10. So one by one we are going to, first I am going to solve that left hand side. Here you can see this one, students. Here left hand side is this one, A plus in bracket B plus C, means that A, so we are going to put that value, putting the values of A, B and C, students. So if I am putting this one, A is equal to -4, so we are putting in bracket -4 plus in bracket B plus C. B is the value of B is 3 and the value of C is 10. So this one I am going to solve. First I am going to solve this small bracket. Here is the -4, same as it is, you will write it, and 3 plus 10, what you get it? You get it 13. And you know that how to solve this one. One is a negative and one other is a positive. So if they are unlike sign, first we subtract that and put that sign of what the difference we get it, put the sign which have a larger integer value. So in this one, which one is a larger integer value? That is a 13, its sign is a plus. So first we subtract this one, 13 minus 4, we get it 9. So its value is a 9. Here I am not going to write it plus 9 because you know that you get it 9 or plus 9, both are same. This one is the left hand side. Now I am going to solve that right hand side. So I am going to erase this one rule. I am going to erase this. Here I am going to solve that one. Here, not a space. So here I am going to solve this one. See this one, left hand side. Here is the right hand side. I have taken this right hand side here. Right hand side is first a plus b is in bracket and c is outside. So here I am also putting the same value of a, b and c. A is equal to, you know that this is a small bracket, and in this one I am going to put this minus 4 and plus b is 3, and then close this bracket and plus c is outside. I am going to write this one 10, this one. So you know that first we solve this brackets, minus 4 and plus 3 both have a different sign. We subtract this one and put that which have a larger integer value. So 4 is a larger, its a sign is a minus. So after subtraction we put that minus sign. So we get it 4 minus 3, we get it 1, and that sign is a minus 1, and plus 10. Minus 1 plus 10, what you will get it, student? You will get it minus 10 minus 1, same is 1 is opposite, both are unlike sign. So we are going to subtract it and get that plus sign because 10 is greater than minus 1. Its a sign is a plus, so we get it. In this case also we get it 9. So see this one, right hand side is also 9 and left hand side also 9. So we can say that addition hold for associative property. Right hand side is equal to left hand side, hence left hand side is equal to for right hand side, and easily we can say that addition holds for associative property. So students, with that example we have I have shown that addition is hold for associative. So we can write that yes, that operation addition holds for associative property. So we can write this one, a plus in bracket b plus c is equal to a plus b and plus c. Next one is condition for subtraction. So students, I'm simply telling that subtraction is not hold for a commutative as well as the associative. So it take time. So I'm telling that it is not hold for subtraction will not hold for associative property. But I will show you with this example. A minus in bracket b minus c is not is equal to a minus b in bracket minus c. Okay, a minus in bracket b minus c and a minus b in after minus c. So I will show you with this example. If a, b, c any 3 integers, then let I will show you for this subtraction. Let a is equal to, if I take that a is equal to 4, sorry, a is equal to 3, b is equal to 10 and c is equal to 7. So left hand side is for a subtraction, this one is for subtraction. Left hand side is a minus in bracket b minus c. We put that value of a, b, c in this one. A is 3 minus b is the value of b is 10, so we can put this value of 10 minus c is 7. Solve this one. If I am solving this one, first we solve this bracket 3, then minus 10 minus 7. You know that what you will get it, 10 minus 7, you will get it 3 there. So 3 minus 3, what you will get it? You will get it 0. Left hand side you will get it 0. Now we are going to solve that right hand side. Right hand side is a minus b minus c. So right hand side a minus b minus c. So first we put the value of a, b, c in this one. A is equal to 3 minus b is equal to 10 and minus 7. So see this one, students. Subtract this one. 3 minus 10. What you will get it? One is a positive, other is negative. Always subtract it and put that sign which have a greater value. Always I am repeating this one. So students, listen carefully. 3 minus 10, you will get it minus 7, and here is also minus 7. Both are negatives. We simply add that value and put that negative sign. So we get it minus 14. So here is a left hand side is 0 and the right hand side is a minus 14. Both are not going to be equal. Hence left hand side is not going to be equal to the right hand side. So subtraction will not hold for associative property. Associative property will not hold for subtraction. Same as it is, I am going to discuss this multiplication over associative property. Associative property over multiplication. So it is also very easy. I'm going to tell you this multiplication will hold for associative. Yes, I will show you with this example. Very easy. If you let A, B, C any 3 integers, then A is going to be multiplied with B into C in bracket is equal to A is multiplied by B and C is a outside. Okay, if left side is equal to right side, then we can say that yes, it is going to be whole. So first we check this one. Yes, I don't know about this one. Yes, first we check this one, then after we are going to write it yes or no. Okay, so here let A is equal to 10, B is equal to 5 and C is equal to 8. I have taken this. A is equal to 10, B is equal to 5 and C is equal to 10. So we are going to check this one. Left hand side is going to be equal to right hand side or not. Left hand side is equal to A is multiplied by B into C. So very easy. Put the value of A, B, C in this one. So first value is A is equal to 10 multiplied by B is equal to 5 and C is equal to 8. You take any integer, no problem. Not only A is equal to 10, B is equal to, you take minus 10, minus 5, plus 8, no problem. All are getting same results. So 10 here, and first we solve this bracket. 5 into 8, what you will get it? It is simply 8 5s are 40. 8 5s are 40. 40 is multiplied by 10. 40 is going to be multiplied by 10. You get it 400. This is the left hand side. If we solve this right hand side is a first in bracket. A is multiplied by B multiplied by C. So first we put this value of A is a 10 and B is a 5, and then value of C is equal to 8. So very easy, students. 10 multiplied by 5 you get it 50, and 50 multiplied by 8 5s are 40. You get it 400 also. So you see this left hand side is a 400 and right hand side is also 400. Hence left hand side is equal to for right hand side. So means that it is also hold, multiplication will hold associative property. So can write that yes, you see this one, it is also hold for associative property. Multiplication will hold for associative property. Next one we are going to discuss with this division. So students, we have checked that addition, subtraction for associative and multiplication. So next one is a division. So I'm going to discuss with division for associative property. So it is very easy. Let A, B and C are any 3 non-zero. Non-zero means that value is not a 0. Non-zero integers. Non-zero integers. Then A divide B divide C. Means A divide B and in bracket B divide C is equal to A divide B divide C. If it is equal, then it hold for division. Associative will hold for associative holds division division operation. But if it is not going to be equal, means that associative will not hold for division. So I am going to check that it is going to be equal or not. Okay. So let that example. Let example. A is equal to, I am going to take this, A is equal to 100, B is equal to 50, and C is equal to 5. I have taken this three non-zero integer. A is equal to 100, B is equal to 50, and C is equal to 5. So I am going to show you with this example. So take this left hand side. Left hand side is A divide in bracket B divide C. See it carefully, students. A is 100. I have put this value of putting the value of A, B, C in this left hand side. In bracket B is 50. 50 divided by 5. The value of C is 5. First we solve this bracket, and you know that 100 division side, 50 divided by 5, 50 upon 5, if you cancel out you will get it 50 divided by 5, it's 5 ones are 5, 5 tens are 50, you will get it 10. So we write there 10, and 100 divided by 10, what you will get it? In this case also you are getting it 10. Means that 100 divided by 10 you get it 10. Left hand side you will get it 10. Now I am going to solve that right hand side. See this one, students, carefully. Right hand side. Right hand side. Right hand side is that one. A divide B divide C. So I am putting this value of A. A is equal to 100. 100 divided by 50. Close this bracket, and divided by C is 5. So 100 divided by 50 is very easy. 50 to 100. So you get it 2 there, and division sign 2 divided by 5. So it is not going to be divided. You will get it in decimal. So you get it 2 upon 5. Division changing to multiplication. 5 comes to downside. 2 upon 5, or you will write it 0. You will get it 5 4s are 20. You will get it 0.4 in decimal. So 10 is not going to be equal 0.4. So it means that it will not hold for division. In that associative property will not hold for division. You see this left hand side is a 10 and right hand side is a 0.4. That one is a decimal. That one is not an integer, and that one is not equal to 10. It means that it will not hold for associative. Division will not hold for associative property. No, A divide B divide by C is not equal to A divide B divide by C. So dear students, these three property related to the 4 operations: addition, subtraction, multiplication, division. Again I am going to repeat this one. Addition, for a closure it hold, subtraction will also hold, multiplication will also hold, division will not hold for this closure. Commutative hold for addition, not for subtraction. It hold for multiplication, will not hold for division. Associative hold for addition, not hold for subtraction. It hold for a multiplication, associative, but not hold for a division. So students, I will attach some examples, some questions related to these property. You will check it and solve it in your homework copy. Thank you.